that. And I'm a square dude, right? Like now I'm recording. People are like, "What the hell are you talking about?" In the middle of a conversation. All right. Oh well, we'll leave it in there. No, that's kind of funny. Let people wonder. I've definitely known wacko teachers who weren't doing things that were square, so we'll leave the conversation at that. Cookie sessions and context. So we're starting to get into some cool meat and potatoes of web development. And, basically just, obviously a cookie is a small amount of data that we can associate with the user. Every time the user comes back to our site, that cookie is persistent. It stays between repeat visits to our site if the user hasn't deleted it, right? And it's basically, one way you can think about it is that, and this is really liberally using the word database, it's a database stored on the user's computer that's passed with every request. And so, Caleb talked about cookies, and when I was asking Caleb about all that, one of the questions I had was, okay, cool, that server's done. One of the questions I had was like, why cookies as opposed to if you go in here and you look at, developer tools, more tools, developer tools right there, right? And you come in here and you look at resources, great, we have cookies, and we can see our cookies right there. But then we also have local storage and session storage. And so over summer boot camp, Ray Villalobos actually taught us some of the stuff about local storage and session storage. But Caleb, I don't know if he just didn't want to go into it or what. But we just stuck with cookies with Caleb. So
the thing with the local storage and session storage is JavaScript's the only one who can read and write to that, whereas cookies are basically server part of the request.
That's cool.
So it's a lot easier for just a server-side stuff to pass data around with it.
Yeah, so if you want to use JavaScript, you could start accessing this stuff. And what's the difference between local storage and session storage?
Session storage goes away when your browser turns off.
Goes away when your browser's turned off, and this will persist.
Mm-hmm.
And then you could re-access it when the person logs back in.
Yeah.
That's cool. But there's like so much information this summer. Yeah. It's like, I know we talked about this, I just don't remember the details. I'm glad.
Local storage and session storage are much bigger, but they can only be accessed by the JavaScript, who can then pass the data on to the server using an AJAX call if needed. But still a lot of extra work, especially if all you're trying to do is sessions, which cookies are designed for.
But ultimately, this is probably the route you want to do it, right?
No, if you're just using sessions, cookies are the way to do it. That's what they're designed for.
Unless you're building for Europe, then you might want to think about that one.
Yeah.
Because Europe, you have to ask the user for permission to use cookies, and they have to say yes.
Europe doesn't like cookies.
So cookies are a tool for us as web developers. We can use cookies to know if we've seen the same user before. It makes it possible for us to implement logins and sessions. Cookies are the most common way to implement sessions. In Europe, you have to notify your user that you're using cookies. You can see cookies in your Chrome browser. We just saw that. So that's where you see the cookies.
Since HTTP is a stateless protocol, there's no state saved on the server about any previous requests. The cookies are a way to get information from the previous request, basically. You save the cookie on their server, or not on the server. You save the cookie on the client's web browser, and
sorry, I just have to bring this up.
you save the cookie on their web browser, and then every time they go back to your web page, they'll send you the cookie back with the request, so you can see what happened previously.
Uh-huh. This should say Go is for cookie.
C. Yeah,
C is too hard.
Yeah, especially getting a web server working in it.
Every time a user goes to domain, if there's a cookie from that domain on the user's computer, that cookie is sent along with the user's request to that server. And the server can use this information to know the user's identity. How do you set a cookie? You have func set cookie. And I'm not sure what package this is in. Actually, now that I say that, I do know. But what would you speculate? Where would you find func set cookie? What package? In Godocs standard library. Where do we find our servers and our listeners and all that? Huh? NetHTTP, right? So, we're doing stuff on NetHTTP, and we could just look, and I'm going to feel like, ooh, it's not here. Set cookie. There we go. Set cookie. And so we have set cookie, and we set cookie, and it takes those two, right? Takes a pointer to a cookie and response writer. So that means we should have here somewhere a cookie. And so here we have type cookie and func, and so this is takes a pointer to a cookie and returns a string. So that looks like, the string method will print out a string. It returns a string. So that's a method attached to it. And we have a cookie jar. And what else do we have with cookies? We have request, add cookie. So add cookie to request. Automatically gets done though, right?
These are for sending requests out with the get
Request.
method or post method.
Request with the get method. Oh.
Yeah.
Oh.
This section here is for
Okay.
requesting from other people.
And then down here we have response. I thought this was the request coming in from
Yeah, that too, I
from
guess.
clients,
but
right? It's not the
That would
client
be for
part.
getting there. Yeah, that would get from them. So, but type cookie doesn't have most types in the standard library have got a new method of some sort, a new function that creates one for you. Cookie doesn't. It's a simple enough type. They just say, here's type cookie, you can fill it out.
Yeah. So how would you I'm asking everybody here, set cookie. It's going to take a pointer to a cookie. Here's type cookie. Well, let's go look at cookie, right? Type cookie. How do we get a pointer to a cookie so that we can set it? Yeah, okay. Var star cookie, and then we could add in some fields, right? Let's see that. Or we will see it in a second. So here is what's happening there. Where's this cookie coming from? The server or the client? What's the response header? Does that come from the client or the server? Server, right? So the request comes from the client, response comes from the server, and so the server is saying set this cookie and it's sending it to the client. And then down here we have request headers, and here cookie, my cookie, some value that's getting sent from the client. It's the request, right? Requesting something from the server. It's getting sent from the client to the server. And so that's type cookie struct with those fields: name, value, path, domain expires, raw expires, max age, secure HP only, raw, unparsed.
So of those things, you probably only need name, value, and sometimes max age. The max age is tricky though with its effects. Max age with that's equal to 0 means no maximum age, keep the cookie forever. Max age that's a negative number means get rid of this cookie. And then max age that's greater than 0 means this is how many seconds you should keep the cookie around.
I love that this stuff is all just like so commonsensical to you.
And then since Go defaults values to 0, that means if you skip max age, it's going to default to 0, which is the keep forever. Which is why they chose that as their keep forever value instead of just having you choose some really high number in seconds.
Cool. Here's how you set it. So just getting the language correct that we use to speak about this language, I would be tempted to say that this is anonymous struct literal. Would that be the right way to describe that?
I think so.
What are your guys' thoughts? Literal to value, right? It's a struct, and it's anonymous because I didn't assign it to a variable.
Yeah, it's a struct literal, but you're not actually setting, and you're just wanting the address of it. So yeah,
It's a built-in struct, right?
Yeah, that's this right here, right? So cookie type cookie is struct, and it has these fields. And so here we have set cookie requires a pointer to a cookie. So we're saying in the HTTP package, right? We have this type of a type, and I'm using that, and then I'm going to use it in this way to create a value of this type. Here's the value of this type, but I'm not assigning that value to any variable. I'm just using it right there. So an anonymous struct literal.
great example though of the Go's defaulting everything to 0. There's a bunch of possible arguments there for cookies, and you only have to worry about 2.
So that brings us back to, by defaulting to 0, you're talking about 0 value, what we've mentioned before in Golang.
If anything, any variable in Go that's not set to something explicitly is set to 0, the 0 value. So which, for cookie, that means defaults.
So here you can see in Chrome, there's the cookie. Go into Developer Tools, go into Resources, look under Cookies, click on Localhost because I'm at localhost, and there's the cookie. So we are setting the cookie, and it takes our HTTP response writer and then pointer to a cookie. So that's what we set. And then here you can see the cookie and then the value. There I am. So how do we get a cookie? So if we look back here under request, right? So request is coming from the client, and we have add cookie, name string, returns a pointer to a cookie and an error, and then cookies gives us a slice of cookies, pointers to cookies. So I'm thinking the request right here.
Yeah, I don't think add cookie is used by the server too much. I think that's used internally by the HTTP library to when it's putting the request struct together.
So the request is right here. That comes from the client, right? So then we got this. So from the request, right, when a client sends a request, they might send a cookie. So from that request, in that request data, give me the client's cookie if it's there. That's kind of what that's saying. Right, and so if we look at that a little bit more closely, right, the request cookie here is takes the name of the cookie. It's a method attached to that request, and so that's this part right here, the HTTP request, right? So we're actually talking about that type right there, and then it gives us a pointer to cookie and the error right there. So cookie returns the name cookie provided in the request. And so here we see this in action. So we set the cookie, listen and serve, and then request cookie if it's there, give me that, and then print line the cookie and the error. And so when I run this, my cookie some value nil. So error is nil, and the cookie is my cookie equals some value. So that gave me a pointer to a cookie, and then I could just print that cookie. That's cool that it figures that out, right? Because it's almost like you think that it'd be the address, the pointer. But println somehow figures out to give me the value. I don't have to dereference it, so to speak.
I think it's from it having that string method. It's probably an interface.
The string method. It's got that string method.
That's probably an interface or something that println picks up on.
Yeah, totally, man.
That would
So
be my guess.
What Daniel's talking about is here's cookie, right? And we have a pointer to a cookie. And so I'd almost expect when we print that just see a memory address because it's pointing to that memory address. But then right here in type cookie, and I was looking at this last night, we're going to see this again. But if you look for a string, and this is like also in Java, just straight up Java, like they have the string method which you could call on things and it will just print a string. And so here you have a pointer to cookie, it's got the string method and it returns a string, and so then it'll just print out the string. That's a whole lot of logic just to print the string. So that's what it looks like in Developer Tools under Network. So Network and Resources, right? Two different places. We're under Network, and we click on that file that we got. I'm not sure what am I talking about here. The request, and then it went to the server, and it came back, and the server served it to us, and then we could click on this file because we received this file, and we could see our request headers and response headers. So this came back from the server, and then this was what we sent with our request. Right, and so we sent that. That was coming from the client, and then we got that by using the request cookie right there. So that's just looking at it in Developer Tools, and then you could also come over and look at the resources, and you could see, hey, there are those cookies, right? And if I clear that, so I just right-clicked and clear those cookies, then I no longer that will no longer show me, hey, the cookie's not there, right? It shows named cookie not present. HTTP, named cookie not present. And I bet if we looked in here, find named cookie, I was thinking that would show up as one of the errors, but it's probably some code that pulls that in.
It's probably from a different Go file.
Yeah, so it'd be like some pull up this error code, right?
Error cookie not found.
String string error cookie not found. Somewhere in there.
Yeah, because the method from request says that it returns error cookie not found if there was no cookie by that name.
So then going to session. So to create a session, we could create a UUID and set it in a cookie. How many people have heard of UUIDs? Never heard of UUIDs? Cool. A UUID is a universally unique ID, and there's more possibilities of combinations for UUIDs than there are atoms in the universe. That's what Caleb said over the summer session. That's hard to fathom. But in which case, when you create one, nobody else has ever. The probability of somebody else getting that ID is infinitesimal.
Although that would be a really, really weird bug if it ever does happen.
I never ordered this from Amazon. So sessions, a user logs in until they log out. That's their session. Sessions create state. We want to know a user is logged in for each of the requests. And UUID is that universally unique ID. And you could find a package to do UUIDs by going to Go Search. I haven't ever talked about that in this class. I don't ever really use it, but Go Search is where you can look for Go stuff, gosearch.org, and so you can search for UUID, and then here you get different stuff about UUID, different packages and things like that. New7 hatch, right? Top result. I don't know how it figures out which ones to show. And then there's also GoDoc.
I just prefer GoDoc's
Me too.
results.
Me too,
Better.
dude.
It looks nicer here.
And so that's same here as New7 hatch, right? UUID. And so let's see how that works. So here's New7 hatches UUID, and we have the index of the different things you could do with this package, and we have different versions. So we let's see, we have this takes these things and gives us that. This takes nothing and gives us this. This takes these things and gives us that. So we got a couple of different versions, version 3, version 4, version 5. And if you look at the way those are described, we have generate a UUID based on MD5 hash of a namespace identifying a name, generate a random UUID, generate a UUID based upon SHA-1 hash. And so this is the one we want. We just want a random UUID. And just heads up, because we're going to look at this in a second, a UUID is an array of 16 bytes. Right? And so if you click on example for the version 4, this is what the example looks like. UUID new v4 gives us a UUID version 4, and then we could print line that to see what that looks like. All right, so that gave us a pointer and an error, and pointer and an error. So you'd need to go get this package to use it. Go get the package. And for those of you who might be watching online, you just do this at the terminal, and you got to make sure your workspace is set up correctly. And to set up your workspace correctly, go watch previous videos on this playlist. Once you have that downloaded, you could then import that package right here. You'll have that code, and you can use it. And so we're going to reference Go UUID. And so somewhere in here, I'll have Go UUID.
No, you just have plain UUID.
UUID. What a trip.
This is an example of them having a package name that's not equivalent to the folder name. They say package UUID.
Oh, wow, that's weird. Yeah, that's not, I don't think that's idiomatic, right? You're supposed to have your package name equal to your folder name?
You can do either way, but it's clearer if the package name is the same as the folder name, because then it's easy to figure out what it is.
All right. Yeah, that was a curve. So listen and serve, handle func, cookie, request cookie, session ID. And so here we have the session ID. And that's just like the name that we'll give to our cookie, and then we're creating a new UUID and setting it to ID, and then we're setting a cookie, right? So if cookie is not set, right, when we ask for the cookie, we'll get an error, and so if the error is not nil, right, there's no cookie. Well, let's create a cookie. So we get a new UUID, and then we're going to set our cookie, which we've seen before. We're calling our cookie session ID, and we're giving it a value of ID string, right? So there we see that string method again. And so that will take the UUID value and turn it into a string. And then we set the cookie, just checking to see where that is, and then print the cookie right there to standard out. That looks a little bit funny to me, that So, oh, that's still inside the if. Okay, this is just right to there. Right, cool. That's what I thought it wasn't inside the if. I'm all, what the heck? Why are we setting it if that's outside the if?
So this basically says, give me your ID if you got one. If you don't, here's your ID.
Yeah. And so there's the string method in that package, right, to get the ID into a string form. And so here we are setting, right? So the response header is coming from the server going to the client, and we're saying set this cookie, and the cookie's name is this, and that's the value, and there's the UUID. And we could also see that here in Developer Tools under Resources, localhost, that cookie got set right there. And so if you refresh, the cookie's value will remain the same. And if you delete the cookie, you get a new UUID. And to log a user out, you delete the cookie. So when you refresh, right, it'll ask for the cookie, and because there is a cookie, there won't be an error, and so all that will get skipped. So session, storing other info in the cookie. So you can store other information inside the cookie, not just the session ID. And what that would look like is here, you get the UUID, and then you could just add spaces and separate and add other strings in here. Right? You could add JSON, whatever you want, any string.
Although in this case, you'd almost want to just use multiple cookies to make it easier to get the data back out.
Yeah. Well, when a client makes a request to a server, if they have multiple cookies for that domain, it sends all of them?
Yes. Which is another reason why you don't want to go overboard with cookies, though, because that data has to be sent back to you every time.
Every request. Which also becomes expensive if it's mobile or whatever for your client. Example of storing user info in a cookie. No UUID used here. So just storing user information in a cookie. That's just storing a string in there. We've already seen that. So setting the cookie, and then that's storing just user information. And then resources, that's storing user information. So to do sessions in 4 minutes, we're pretty close to the end, and or not. People can manipulate cookies, and so you have to find a way to know if they manipulated them. And so you could use hash-based message authentication code, HMAC, and you can look this up on Wikipedia. But basically, it's just like getting a hash and knowing and having a key, and then if they change it, the hash will be different. And kind of like we did when we downloaded Go, it had the checksum, the SHA checksum or whatever. And so that tells us if the file's been changed from the one they intended to give us. And so it's the same thing. We could tell if somebody's manipulated the cookie, and that makes it secure. And this is all really convoluted and kind of complex, and we're not going to. Caleb didn't show us this over the summer, but he said, "Hey, be aware of it." And this is the way you do it. But we're going to end up using a library to kind of do all this for us. But just a little bit of exposure to how this works before we go and look at the library. So the downside of the cookies is the user can change the content. You can't trust the content, and we can protect against that with HMAC, and it prevents cookie tampering. And Go's got a really great crypto library. That's one of the places Go really shines. And so here, godoc.org, right, we have the crypto library and some of the different ways we could hash stuff. And then here is crypto HMAC, right, where to get an HMAC, we do right here, you can see it's new, and it takes a function, right, that returns a hash. And so here we're doing HMAC new, and we're giving it SHA-256 new, so a function that returns a hash, and then a key, which is a slice of bytes. And so that's how you would create HMAC. And then here, we use SHA-256 right there, and you see SHA-256 is, it returns a hash, I guess, because that's what it needed. I'm not seeing that intuitively. Right there we go, new hash returns a hash. And there's a big red arrow. How do you like that? And so here's what that code looks like right up there. And, I think we're pretty much out of time. Unfortunately, I like ending at the end, but we don't have enough time to do all that. So I guess we'll pick up here with this on Thursday. Anybody have any questions? How many people got something good today? Just checking in. Cool. Try to provide you guys some good value every class. Move the ball forward. And we're at right now in Caleb's training, we're at like day 8 out of 17. And so we got about 17 weeks in the semester, and we're in, I think, week 7 of the semester. Is that right? So we're, tracking it pretty much 1 week per 1 day. And it kind of gives you a measure of what you'll get out of this class. Like, okay, look, we're at 8 out of 17. We're about halfway. Wow, I've got, some, halfway, and we're at sessions. What's going to come in the next half? And so we'll be breaking new ground for those of you who did this in the spring. We kind of got up to this point here. So we'll be getting into new ground and App Engine and everything. Anyhow, all right, I'll see you guys Thursday. Thanks for coming. Nice to see you.